Oren Razon, co-founder and CEO of Superwise. Welcome to the Data Exchange podcast.
Hi, Ben. Thank you for inviting me.
All right. So, according to your website, your tagline is streamline your model observability. So, for our listeners who are familiar, broadly speaking, with the different stages of machine learning, so in my mind, Oren, it would be like you start with some sort of data processing, data transformation, then model training, model tuning, model serving, and then along the way you have some sort of orchestration tool that is stitching together everything. But this when we're talking about observability, this happens after you've started serving your model, and many of our listeners are familiar, roughly speaking, with the notion of monitoring your model. So what is the difference, Oren, between monitoring and observability?
Cool. So first of all, I think that's a great question because one of the first things that we think about when we talk about observability is monitoring, but observability is actually much bigger than that. And I think even if we look on the software ecosystem, we could see that the observability term started to become very popular. And that's because monitor usually talk about a very, simple point in time where you're looking on the data, you're looking about the stuff in production, and you want to give the alert at the right time. But observability is much bigger than that, because when you go and talk with data science teams, when I started the company, we went to talk with a lot of data science teams, and I was asking them, what's the performance of your model in production? And they said, actually, I don't know. So it starts with visibility. It starts with being able to understand what's going on in production. Then you need to monitor that. But then it's not enough just to get the alert. You need to be able to troubleshoot. What is the root cause? Why it happened? Was it because of internal data pipeline issue? Was it because of an external change? So the troubleshooting process. And then afterwards, also being able to manage the issue and lead it until you resolve it. So being able to do all the four things, being able to understand what's going on. And we'll talk about it later on, but when we're talking about visibility in machine learning models, it's also include being able to understand the black box, being able to get explainability inside, being able to trace back what was going on. So being able to visualize what's going on, monitor that, lead you to troubleshoot it, and then to lead you to resolution. That's the bigger picture when we talk about model observability.
So machine learning, as you alluded to, is probably more complex than your typical average piece of software. So observability in the context of machine learning is particularly challenging because
when you talk about observability in software, the traditional metrics are there. CPU, memory, disk utilization, all of them are usually already there. When you talk about doing model observability, we as a solution in that space, first we need to take the data and to create the metrics. The metrics are not there. We need to be able to calculate drift. We need to be able to calculate the quality of your data. So first of all, it's not only about being able to visualize the information, but we need to actually to create the information. So that's one. And the other
and Oren, let me stop you there. For our listeners, I think the subtle thing that Oren is saying here, and correct me if I'm wrong, Oren, is that in machine learning, the metric that you're measuring is somewhat quite specific to your application and your model, right?
Mm-hmm.
And your context, right? So it's not like you can just say all my models will measure the same thing.
Exactly. Performance measurement. For one model, it will be accuracy and F1 score. For another one, you want to look on an aggregated window and calculate precision normalized by something else. Exactly. So there are a lot of different metrics. You need to be able to customize them for the specific use case. So that's one thing. The other very challenging thing is that it's dealing with data. Everything around model is around data, which means that everything is stochastic. When you go and talk with a DevOps that need to monitor his IT applications, you will say to him, how do you know how to set up the right monitoring alerts? He will tell you, anything above 80% CPU is bad. Everybody could understand that, and that's a very reasonable thing to do. When you talk about model, what will be the level of drift or the level of missing value that you should worry about? I don't know. For one feature, it could be that it has a lot of missing values on a regular basis, and for another not. It could be that for one use case, we have a lot of variability and therefore a high level of drift. It's something quite normal. So being able to understand what is the right norma, when do we have deviations, and being able to do that in a very high dimensional space, that's a very challenging thing to do. That is not quite equivalent to what we see in the software ecosystem.
So Oren, as you were speaking there, it just occurred to me. So in typical observability, software observability, like you said, so they're somewhat standard, accepted metrics that people use. Here, it's very specific to the modeling technique, the use case, and so on and so forth. So does that mean that in the observability team, in the context of ML, will need to include ML experts to interpret the, so if you have readouts from the observability tool, how will a DevOps person understand these readouts, right?
So you're saying, should we have an expert on the other side to be able to understand?
Yeah. So in a model observability team, do you need some ML expertise, right?
So that's a good question. I think that right now, as we see the market, I see that mostly the technical persons from the ML ecosystem need to be there in order to interact with the different platforms and also in order to resolve the issue. Because eventually, if you need to retrain the model or if you need to do something else, you need some kind of data scientist or somebody that are able to do so. But I think one of the challenging items that we are facing in the ecosystem is to simplify everything, to simplify and to be able maybe to give to some kind of an expert to customize or to build the rules, but eventually to build some kind of automation or some kind of, I know as an expert, what are the kind of issues that I want to detect, and I want to express what I want to do whenever those type of things happen. But then I want sometimes even the automation already to do that for him, or to have a very simplified alert for the more domain subject experts, the domain one, not the technical ones, to be able to understand that there is an issue and why it's happening. And I think that's one of the key challenging aspects that we are facing with, how to simplify everything and to provide a very simplified view to less type of expert type of users.
So this is a hard question. It may depend on the model type and the use case, but feel free to kind of parse it depending on the context. But in your mind, what level of automation is possible today on the observability side? Because you talked about being able to, observability includes not just alerts, but kind of root cause analysis and maybe even fixing the problem. So what level of automation are you seeing?
So first of all, today, not talking about Superwise, but talking about what we see in the industry, we see is almost zero type of automation, because we could talk about even before talking about solving the issues, there's still lack of automation in being able to deploy stuff to production. Sometimes we still see teams that are deploying, manually an artifact that is being delivered through email or through Slack between the data science team to the engineering team. So there's a lot of things in the automation that are still even before solving the issues or monitoring or automating the observability stuff. But as we see the movement toward the automation, towards standardization, I think that there are already all kind of stuff that you could automate in the process. For example, some of our customers are automating the process that whenever a drift occurs and whenever it's on a specific level of very important features and so on, they could automatically retrain their algorithm. Or for example, if you know that the performance level of your algorithm is already below a certain point, you could automate the ability to automatically drive the prediction to work under a safety net, for example, to drive them to a business rule engine instead of the algorithm right now, because the algorithm is not stable. So there is a level of automation that we start to see among our customers, and that's something that we are really working closely with our customers to understand better the processes that they are doing after understanding the issue in order to enable them to automate this process.
So in the data engineering world, the data pipelines and all that, there is this kind of aspiration to inject more software engineering rigor, right? So they're talking about tools for, let's say, testing pipelines before they deploy it. So in the ML world, I guess you're on the observability side, but I imagine observability tools have a role to play when it comes to testing models, unit integration testing. So what are you seeing in terms of level of sophistication of teams, in terms of injecting that sort of software engineering rigor into how they build and deploy and test ML models? And do you folks see yourself as playing a role there?
Cool. So we start with the second question, and the short answer is yes.
Yeah.
And I think, like, as we started the company, I think the biggest value that we provide to customers is being able to be there and to be the observability platform for the production aspects of what's going on, because that's where you could actually make sure that the ROI that the models should give you is working as expected. But as we move on, and as companies are starting to become more mature and starting to automate the process of model deployment, of doing research in a much more standard way, we see a lot of opportunities to expand observability to actually to be the model pipeline observability. So we won't only monitor the production pipeline, but also the processes around it. For example, you talked about the equivalent in software ecosystem. So let's take the concept of CI/CD. Whenever you want to deploy a new model, instead of just replacing the model artifact or just routing all the new traffic to the new version, you could apply practices from the CD world, which is, for example, in software, you call it canary deployment. So here you could do A/B test rollout. You could start and route traffic to the new version, and you could test whether it's actually working as expected, yes or no. In some cases, you could even do that in a shadow mode. So there are a lot of things that we could do, even in the process of building the model, validating it, giving you insight around it, and then also about creating a safe deployment process to production, and then, of course, to monitor that in production.
So I guess so this whole CI/CD and various modes of deployment, best practices, these are well known in software engineering, and there's a lot that the ML community can learn from years of best practices there. But so I don't know if this is something you've thought about. What about testing models? So in software they have QA teams, they have
unit testing.
They have unit testing, integration testing. But in ML, I guess it's kind of quite difficult, right? So, because basically, what are you testing? Is it the training loop? Is it the accuracy of the model? Is it something to do with your data set, right? So there's so many things, because in ML, it's not just the model, but there's also the data that you have to make sure is aligned, right? So, I don't know. So what's your sense of how rigorous people are in terms of what they do before they actually deploy?
Cool. So first of all, you're right. In models, we're talking about a combination of three: the code, the algorithm, and the data. So you should be able to test all of them. And while the code is usually being tested in a more standard way, like unit testing and others, the algorithm or the data should be tested in an other technique. So there are a lot of things that you should be able also to test before deploying. So some of it relate to the data, as you said. For example, let's do an analysis of your training data set versus your test data set. For example, let's give you the reflection, whether the test data set is actually looks in some ways similar to your training data set, whether you might have a leakage inside. So there are a lot of insights that we could also provide on the data set level. We could take the same type of ideas, the same type of metrics from the production monitoring that we're doing, and to apply that on data sets that are there and being tested even before production. So we could test a lot of things about the different data sets that are out there, and we could give you the insights whether everything looks good or bad, or something suspicious has been detected. And also we could,
and Oren, another complication that you alluded to earlier, the whole thing is stochastic, so you might have to test multiple runs, right?
Multiple runs for multiple even samples, so you could see how stable it is. And to add to that, you could also monitor. We talked about monitoring the data aspects of between different data sets, but you could, as you suggested, monitor the actual model performance. You could also provide you insights regarding the test evaluation accuracy, of course, but you could also get insights like weak spots. Hey, we are going to deliver a new version that we could automatically detect that there are specific subpopulations that are less optimized using our existing model. For example, we detected a subpopulation which is relatively small that is underperforming right now. Maybe that's okay, but what you want actually to do and connect it to production is once you detected this subpopulation that is actually a weak spot or vulnerability of your existing model, you want to monitor in production that this subpopulation is not growing and not starting to appear much more in production. So everything is actually connected, and the insights that you could derive out of your model evaluation should be directly injected into the production monitoring and be actually one of the key elements in your ability to configure the right type of monitor alerts that you want to do there.
So what's your sense? You mentioned earlier the notion of CI/CD for ML, which includes, among other things, the ability to just handle various modes of deployment, A/B testing, canary. And by the way, there's also a kind of deployment that has some more complicated logic, right? Which is basically, if the data looks like this, use this model. If the data looks like this, use this other
routing
model.
Logic, yeah.
Yeah. So what's your sense of teams out there in terms of their ability to handle these various different kinds of deployment? I mean, are we kind of talking very advanced teams here at the moment? Because maybe most teams can just say, okay, we're ready to deploy, let's deploy the model. That's all they can do at the moment. So what's your sense of the level of sophistication of the average teams?
So I think that, like in every other thing that we will talk in the MLOps ecosystem, it's always a combination of two: lack of tools and the technology, and lack of practices and knowledge. Because, by the way, that's an interesting insight that I have, that even that we provide the right tools, like the next question after integrating with model observability is, okay, so what are the right processes right now to do above it? What should be the estimate process?
Because ops people have very, very rigorous processes, right?
Yeah, and data scientists, ML engineers are still not very, there's like the two-edged sword here. Like data science used to complain that they are not in production, they are not seeing value out of it. But now that everybody wants to see that in production, they need to be able to face with challenges from the ops type of world, which is a new thing that they should get used to. So going back to your original question, I think it's a combination of lack of tools. Right? Until now, there weren't tools like Superwise that give you the ability to easily implement a logic of doing A/B test of your model rollout, or some kind of a more complex or even a multi-arm Benedict type of release management where you could dynamically allocate it according to the performance of each one on each subpopulation. So it's a combination of tools, but it's also a combination of knowledge and understanding that it is important. So I think that the knowledge thing is something that we are playing a large part of it alongside other companies to educate the market, and as well as tools are starting to get more mature. So right now, still only very sophisticated teams are doing such kind of releases. But I think everybody that will start to scale, and in the coming 2 to 3 years, everybody will have to do that in order to reliably scale their AI operation.
So rather than ask you the question directly of build versus buy model observability, maybe it's better if we just describe what are the key components, key features of a model observability platform. And you can start with kind of like the minimum viable observability platform and then layer on some more advanced capabilities. So what's the minimum viable observability platform?
So as a key lesson learned from the last years that I've founded the company, I think even before talking about the value, something very important to understand is that the integration should be super easy. Nobody will start to use your product if the integration is complex, even if the potential value out of the product is super impressive. If the integration is complex, nobody will walk in a closed garden. Everybody wants that everything will be super integrated. Like when I'm using Slack, it's integrated with my Zoom, it's integrated with everything, it's integrated with my IDE, it's integrated with my Git. I want the same experience in the ML ecosystem. I want the model observability to be easily integrated to any kind of platform, to any kind of a common alerting mechanism.
Model, any kind of model server, right?
Exactly. So any kind of feature store. So a very key element, it's that you can't be a closed garden. You can't be something that is super complex to install, super complex to integrate with, or don't integrate nicely with other tools. So that's a first key element in any kind of model observability platform. And we put a lot of emphasis on that. We are obsessed on creating the easiest integration and most integrated thing in the ecosystem. Now, given that, the first thing is being able to deliver you visibility. And we talked about it. We talked about the fact that we need to actually to create the metrics. So from one end, we need to be able. So that's the first part, being able to integrate easily into the existing ecosystem. Now, then once you integrated, from one end, you have to create value fast, which means that, as we talked before, you don't have metrics in place, and every use case might require other metrics. So one key element is to supply you all kind of out-of-the-box metrics, for example, data quality metrics, drift metrics, and statistical analysis like entropy, variance, and so on.
And Oren, this is because, as we discussed earlier, metrics in ML depend on the model and the use case.
Exactly.
Right.
So there is the combination of being able to provide you a lot of metrics out of the box, but also to give you the ability to customize and build your own metrics based on your specific data. So being able to show you and being able to see all of those metrics in production and being able to do that in high resolution, which means that being able to understand what's going on in a specific subpopulation. Because, everybody know about things that going on in a macro level. Like if there is a concept drift because of COVID, everybody are aware of it. But if there is a concept drift in a specific merchant, in a specific subpopulation of your entire use case, that's something that could slip away without even being able to notice if you don't have the right visibility in place. So being able to see all of those metrics that should be customized to your specific case under a very high resolution, that's a very important, and being able to slice and dice and to be able to see that in the specific resolution that you want, that's a super important piece. That's the one. The two, as we said earlier, is being able to monitor that. You don't want to create another place and a lot of new dashboard that you need to look and search every day for the anomaly. You want somebody to alert you whenever you're sleeping, or not when you're sleeping. Whenever you arrive in the morning, you want to know about the interesting stuff that's going on there. So being able to configure the right monitoring policies that, for one end, give you the flexibility to define your own threshold versus being able to understand automatically whenever there's an anomaly or trend, are the second very important element. And the third biggest important element is being able to manage the incidents. being able to manage the cases that were discovered. So it should give you the ability, as we said, to troubleshoot and to go back to your raw data or to see the distribution and to understand what was going on whenever there was a new bias. So you want to be able to analyze whether this bias is due to what features.
So Oren, this last thing that you're describing ties back to that first thing, which is the integration of the tool, because basically in order for you to do this diagnosis, you have to be able to integrate to data sources, feature stores.
Exactly. And to say to you that the bias is happening because of a sampling bias that you had in your training data set, it means that you should be able to connect to your training data set to understand that. So being able to connect to the different places in the process is a super crucial element in order to give you the ability to troubleshoot and to fix the issue.
So let me have you elaborate on this, because basically, technically speaking, a model observability tool is not real is a different stage of the ML pipeline, right? So basically, there's the model building, model tuning stage, and the model observability tool is separate from that. It has nothing to do. So a strict model observability tool had no role to play during model training and tuning. So but you're saying a good model observability tool should still have visibility into the artifacts and the things that were used during training.
So I will take the sentence that you said and we'll try to pivot it a bit. I think model observability start to become relevant once your models are operational, which means that if you still are in the research phase or in the engineering phase of implementing the algorithm, model observability is still not a key piece. But once it's there, once you deployed it, model observability should be there not only on your serving pipeline, but also on your training pipeline, because a good model observability should give you the full visibility about what's going on regarding your operational models.
So what aspects of your training pipeline is the model observability tool integrating with? Is it the experiment management, the model catalog? What exactly is a good model observability tool sinking its teeth into?
So it basically should be able to integrate with the model registry or model artifact store. That's one piece. And the other piece is the training pipeline. Still, maybe in some places you still don't see an automated training pipeline, but in the more mature places where they're already implemented some kind of automatic training pipeline, which take data set, run a lot of experiments, do the feature selection, and then select automatically the right version to deploy to production, then you could also need to be able to connect to the pipeline, to measure the pipeline and to measure the different data sets that are being output from this specific pipeline, to be able to then to go back in production and to say, hey, I want to give you the ability to compare your production results to your test results and to give you the full visibility, which again, the must-have piece is the production one, but being able to see the bigger picture and the bigger context is an important aspect in a mature observability solution.
So to make it more concrete, so Superwise itself integrates with things like MLflow then?
Yeah, actually, we are going to release a new blog post that explains exactly how to do that in the coming week. Yeah.
And then Superwise itself integrates with all of the major model serving.
Exactly.
I see. And so what about the advantages of being a software as a service is clear, but are there disadvantages as well? I guess you cannot work with heavily regulated industries that require everything to be on-prem, right?
Yeah, so that's an interesting aspect. As a founder of ML infrastructure company, I'm also 50% of I've started my legal studies and I'm almost a lawyer. So I think that eventually when you're talking with teams, everybody want to use SaaS. Nobody want to start and, bootstrap or installing things or managing their own specific infrastructure for solutions. So that's why we put a lot of emphasis about security. Even our SaaS solution come with SOC 2 Type 2 compliance, is GDPR compliance. We provide a single tenant kind of approach where each customer actually being deployed on the specific data center that you want that and is totally isolated from others. And everything, of course, is encrypted and the highest security elements that required. But still there are places, especially at the enterprise level, that they enforce you to not take any data, any information outside of their internal network. And understanding that, we also provide a very easy to use, easy to implement installation kit that could be easily deployed in any kind of cloud environment, Azure, GCP, AWS, in any kind of environment, because it's totally agnostic to a specific, proprietary type of technology in a specific cloud provider, and therefore everybody could, choose the right flavor for them.
So let's close by talking a little bit about broader ML trends. So the first trend I wanted to bring up was kind of this whole injecting software engineering rigor into ML. So we talked about CI/CD for ML, testing, unit integration testing for ML models. So anything you want to add there in terms of what you're seeing in terms of this notion that more and more teams need to kind of really become more rigorous in how they use machine learning. So are you hopeful that this is happening?
I see that it's happening. Actually, the first Medium blog post that I wrote in my life was exactly about the aspect that data scientists should embrace from software engineers. And there are so many that we didn't mention, and we could put so many out there. For example, code review. Or so, a data scientist writing a training process which will eventually create the model that will be deployed to decide whether to reject or approve loan request. And nobody is reviewing that the data scientist didn't write the process with a data leakage side.
And documentation, right?
Documentation, reproducibility, being able to go back and understand on which commit or which data set exactly and which scheme of data set did you use. So all of that, we're seeing also a lot of other solutions. For example, we have good friends which are Dogs Up, which are working a lot about being able to reproduce your
so a key theme in what you're talking about is some notion of teamwork and cooperation between units. So are you starting to see this happening?
Yeah, a lot. And this happened before in the past, like you saw only one data scientist sitting alone in the dark working on the stuff that he was working on. But now that you see the teams are going to 5, 10, 20, and even more, or even different data science teams, you must have all kind of collaboration standard in place, and also standards like taking it back to the observability space. How do you measure your model performance? You need to have one single source of truth, being able to use the same standard and the same processes and methods in order to create some kind of standardization across the organization.
So the other theme I wanted to bring up is I think the models are getting larger and more opaque, right? So in language models, and even more complex, like reinforcement learning. So is there anything specific to kind of this growing complexity of models that you folks have to address, or is observability kind of agnostic to the type of model that you're using?
So I think observability should be agnostic and should give you the ability to support any kind of use case. I will say you mentioned reinforcement learning. I think that's a very interesting point. We still don't see a lot of implementation of reinforcement learning in the field, but the ones that are there are very challenging from observability perspective, because it's by definition a dynamic environment where everything is changing, and you need really to be able to understand what are the type of changes that you want to be alerted by, and what are the type of changes that are by definition being driven by the reinforcement process. So that's a challenging environment. And
there's another, so actually, as you were talking, another thing came through my mind, Oren, which is basically multimodal models. So a lot of the times when we talk about a model, right, it's an NLP model, text, or computer vision model, or a model that uses structured data. But in the future, it will be models may use multiple types of data, right? So observability becomes more complex in the sense that it's not I think the metric part of observability, that's fine. It's what happens when things go wrong, and in ML things will go wrong, right? So how do you diagnose as models become more complex and more opaque, right?
Yeah, so I think you're totally right. But I think that we need to separate between the framework of model observability, not from a solution perspective, but from a process perspective. What should be the right framework on how to do model observability? That's, I think, something that is still stable and should be the same for any kind of data, any kind of use case, versus being able to technically measure image type of data versus textual data versus structured data. Yeah, I think from a measurement perspective.
But when you start going through the root cause analysis, observability can help you only up to a point, because it'll integrate into the observability tool will integrate with your feature store and your pipelines and all these things. But if those things are themselves hard to diagnose, then there's not much the observability tool can do there, right?
Yeah, so that's why you won't show that there is a drift in the embedding layer, but you will actually show the actual images that are drifting. So there are different type of techniques and a lot of challenges from a UX perspective of how to simplify the process of troubleshooting the thing. But I think the same elements of being able to go back to the raw data or going back to the distribution of elements that are changing is a crucial point. So not only saying that the performance is dropping, but also to explain what has been changed. For example, the performance of your sentiment classification or image recognition is being degraded, but to show you then the inputs, the actual images that are the root cause for this performance to degrade, and that could be because there's a lot of noise in the image or other elements, but the same process and the same methodology should be also applied to different type of data structures.
But I guess the key point philosophically from what you're saying is that the fact that you have this observability tool probably forces you to think more holistically, because basically it is giving you tools, it is giving you readouts and tools to help you think more holistically, right?
Mm-hmm. Mm-hmm. Yeah, and I will say another use case that we see that starting to appear a lot in the market and is challenging is what we are calling the multi-tenancy of models, which means that, okay, I've deployed a fraud detection model and I saw that it's working great on one customer. Then I'm using the same process, the same pipeline to create a model per customer. So quite fast, one data scientist wrote one pipeline and it produced 10,000s of different models that are out there, and each one works on a different data, and each one could suffer from a different type of drift and different time frames. So quite fast, it's a super high scale type of an issue to be able to see what's going on in 10,000s of different models that are out there, and also to be able to move between the different resolutions, as we mentioned, to understand what's going on in the entire project versus being able to understand that the specific model at a specific merchant or for a specific customer is now drifting and as an issue. So being able to to be able to see and get model observability that could navigate between the different flows of looking on the project level or looking on a specific model or specific model instance level is something that we're seeing as an increasing demand.
So the final trend I want to bring up, and I think it should be clear that observability helps here, but feel free to elaborate, is responsible AI, which is an umbrella term which aggregates all the risks that are associated with deploying ML and AI. So this includes safety, reliability, fairness, bias, explainability, interpretability, and so on. So have you folks seen firsthand how an observability tool might help teams address responsible AI?
So I think the need for responsible AI is something that we are starting to see in the market, and it's still not something very concrete, but people are aware of it, are aware that it will become concrete in the coming few years, especially in regulated environments like the financial environment, the insurtech type of environment.
Healthcare.
So we do see, yeah, healthcare, exactly. So people are aware of it and starting to worry about it. And I think the relationship between model observability to governance or responsible AI is that this is a general term of that under this umbrella, it's also the regulation underneath it and so on. And model observability is actually the tool, the solution to give you the ability to detect the stuff that you need to do under your specific context of being responsible. So model observability is a necessary tool and a must-have tool in order to do responsible AI. But what does it mean, responsible AI, for you is something that is starting to evolve under, and it will become a bit different under different sectors and different verticals.
By the way, I'm an advisor to a law firm that's the first law firm focused on AI. And they helped actually craft the National Institute of Standards framework for addressing bias in ML models. So this law firm is actually the go-to firm for a lot of chief general counsels in big companies. And one of the things they found early on is, the most basic thing that teams can do for responsible AI is just to really invest a lot in documentation, documenting models and things like that. So I wonder if tools like Superwise and model observability tools can, I don't know how you would do it, but kind of coach or encourage teams to document their models even more. So maybe you can do that by in your tool saying, if you're about to turn on the switch for Superwise, we would help better. We could be more helpful if you answered the following questions about your model, right?
So one important element is the one that you suggested. We could, if the more documentation that you will bring to the table, it will be easier for you to troubleshoot issues afterwards, or being able to collaborate between the different team members whenever you look on something in production. And the other aspect is that regulation will come in and will require it from you in the coming few years. So you need to start and get used to the fact that you will need to do that. So start to do that.
Yeah. And with that, thank you, Oren.
Thank you.